Well, good afternoon. My name is Gary Baldwin, and I am the Executive Director of CITRIS, and I'd like to welcome you to one more in the series of research exchange meetings here on these Wednesday at noontime. Thanks for coming. I'd just like to begin by saying that the lunch that you're getting, the drinks that you're getting, the whole sponsorship of this event is thanks to our very good friends at Infineon Technologies. So, Uli Ramaker, if you happen to be watching today, thanks very much on behalf of everyone here. Hello to web viewers. This meeting, these series are webcast not only to our sister campuses at UC Merced, UC Davis, and UC Santa Cruz, but to the whole wide world of webdom. And so we often have many foreign countries logged in, so I'd like to welcome the viewers from around the world. These presentations are also archived on the CITRIS website. So any of you out there who have to leave in mid-meeting, you're welcome to log back in and view these in non-real time. Today we are very pleased to have Professor Tapan Parikh, who is an assistant professor in the School of Information here at Berkeley, so just across the plaza there in South Hall. He's going to be talking about designing appropriate computing technologies for rural development. He's been working on information technology systems for the developing world for the last 8 years. He holds a bachelor's degree in molecular modeling from Brown University, MS and PhD from the University of Washington in computer science. And in 2007, he was named Technology Review Magazine's Humanitarian of the Year. I hope that you will join me in welcoming Professor Parikh to today's session. Thank you very much for coming.
Great. Thanks very much for that introduction, and thanks very much for having me here at CITRIS. So I'm really excited to give this talk here. I think there's a really nice synergy between the kind of work I do and the mission statement of an organization like CITRIS, and I hope that I can do justice to this kind of agenda. Today I'm going to be talking about essentially my dissertation work. I recently graduated with a PhD from the University of Washington in computer science, and I'm going to talk about that work. And I really look at this work as kind of like a case study of how one can balance having both practical and real impact on the ground when you're working on projects in developing countries, and also balance that with a research agenda that generates genuinely new knowledge for the academic community. So the application domain I'm going to talk about today is essentially providing financial services to poor rural people in the developing world. And this is a concept that's called microfinance. It's really a global movement. And one reflection of how important this movement is that the Grameen Bank and Muhammad Yunus shared the 2006 Nobel Peace Prize for their work in spreading microfinance in Bangladesh. I'm going to talk today about a slightly different model of microfinance, which is especially prevalent in India and also increasingly in Africa. And this is called a model called self-help groups, or SHGs. And the real goal here is to build essentially independent financial cooperatives at the village level. And these consist of between 15 to 20, most commonly women, who get together periodically, whether that be weekly or monthly. They collect a small amount of savings from each member, and then that savings is used for loans to other group members. And those loans could be used for things like starting a new business or acquiring some new livestock, getting some education, providing for health care, etc. One interesting thing to recognize is just like the Grameen model, repayment within these groups is based on the idea of peer pressure. There's a knowledge within the group that the money that's accumulated belongs to all the people in the group, which creates a very strong social incentive to repay those loans. And that has had actually excellent performance all throughout the world. And so the underlying goal behind all of this is to actually decentralize not only access but provision of financial services, so people can build their own structures for providing services to one another. So in India, actually, this has been so successful that the formal financial sector has wanted to get involved. And this is actually beneficial both for the groups and for the banks themselves. So from the group's perspective, being linked to the formal financial sector allows them to actually access more credit for undertaking larger projects and at potentially better rates than they can generate locally. It also allows them to access other kinds of financial services which they may not be able to manage locally, things like insurance, investment, savings accounts, etc. From the bank's perspective, these groups provide a really nice virtual intermediary for actually conducting transactions, for monitoring the performance of loans, for being able to follow up with customers on a regular basis. So this actually saves them the effort and the expense of setting up physical infrastructure in the sense of bank branches, tellers, etc. And the actual repayment performance that's guaranteed or provided for by this social peer pressure is actually excellent. It's anywhere between 90 to 98%, depending on where you look. And that makes it a potentially profitable and commercially sustainable activity also from a commercial perspective. However, from one perspective, there's actually a lot of obstacles in making this work in practice. And so actually, a lot of these self-help groups are spread across all of these remote rural areas, which makes it fundamentally very difficult to collect information or money or to build relationships with these groups. Moreover, the group members themselves and the people working with them may have limited education. There's limited infrastructure in terms of connectivity and power. And there's also limited kind of financial capacity for actually building up formal ways of achieving connections with these groups. So these actual problems means that from the perspective of the groups, because of their limited educational capacity, that means their documentation may be often inconsistent or inconsistently prepared or aggregated. And that documentation is the fundamental information that the banks use in order to determine what kind of services could be available to the groups in terms of what kinds of loans or what kinds of insurance plans, et cetera. So from the bank's perspective, it makes it very difficult when dealing with these kinds of groups to be able to decide things like credit risk or deciding what kind of services a group would be eligible for. So what I'd like to propose as kind of the thesis statement of this work is that information can be one way to bridge these formal and informal structures. From the perspective of the groups, having better information about the group members' performance and the performance of different kinds of loans, they can really take more informed decisions in a sense, making loans for things that are more likely to be successful and to members that are more likely to repay the loans. From the perspective of the banks, also having kind of a steady flow of information allows them to generate things like credit ratings and to be able to decide on the varying kinds of risk that would be inherent in providing different kinds of services. So the end goal would be like you'd establish more of a meritocracy. The better groups who have better performance internally would be eligible for preferential service and professional products. So the kind of design problem I'd like to motivate based on this problem is, can we actually design a system that allows us to reliably aggregate and analyze data from these groups that are spread across all of these remote areas? And the kind of requirements of the system are that it should be accessible to the users we would expect to be within the groups and serving those groups. It should be accurate and efficient to be able to capture this financial data. Since it's financial data, it's very important that it be captured both accurately and efficiently. It has to deal with various kinds of infrastructural limitations that having to do with education, limited power, limited connectivity. And hopefully, whatever infrastructure we deploy to provide this service could be used for a variety of other services also. So financial services is not the only service required by rural poor people. They also need things like health services, agriculture, access to markets, education, et cetera. So whatever infrastructure we deploy here, it's only going to be cost effective if we can leverage that same technology to deliver a variety of different services that local people would find useful. So this is essentially the design problem. So at this point, I want to give a little overview of the rest of the talk and also the kind of methodology that I followed. So this is a standard kind of user-centered design approach where the first step is really to understand the context and the users that we're going to be working with really well. So the first step of this work is to really spend a lot of time with the users that this system is supposed to support in the places that they live and they work to really understand what is going on in the local context. What are people's real requirements and needs, and how can we best address them using technology and using improved systems? What that understanding, the next step is actually, as an engineer, I'm a computer scientist by training, so the next step is actually to use this understanding to motivate some new technology or some new system that can address the needs that we've observed with regards to the limitations of the context and the infrastructure that we have available. Finally, the last step is to actually build real applications, to use this technology to build applications that serve well-defined needs of local people and to evaluate the result of those interventions through the impact that we have on the ground. So I'm going to talk about 3 different kinds of applications focusing on microfinance, agricultural services, and public health data collection. So the first step was actually understanding context. And this was primarily done with 3 organizations in India and also 4 different organizations in Central America over the period of roughly 12 to 18 months. So the first step from my perspective is actually to understand the user interface design space for working with these kinds of rural users. So first of all, this includes both the members of the groups and the supporting staff that may work for the local bank or the local nonprofit organization or NGO. So one thing to recognize is that especially the group members, many of them have really a very basic education. They're either working in agriculture or as agricultural laborers, and they may have really only a second or a third grade education, which means even if they are literate, they're probably semi-literate and only have basic ability to read and write. And so there was really no previous work that had ever actually looked at these kinds of users as a target for user interfaces. There was only one previous project that was done in 1997 by the Apple Research Labs, who were looking at essentially literate rural users and looking at them as public health workers that are working in villages and looking at what kinds of user interfaces would help them both collect data from their activities and to disseminate information to patients. They were using a mobile device called the Apple Newton. In our case, we wanted to use a laptop because we wanted actually maximum flexibility in terms of the different kinds of interface variants that we could evaluate with users in this context. And at this point, we weren't really considering how a system could actually pragmatically be deployed. We were much more concerned with actually understanding the user interface features that would be accessible to different kinds of populations. So as I mentioned, the first step is actually going to the field, spending a lot of time with the groups, and understanding actually what goes on a day-to-day basis. So this is actually a group meeting. So most of the transactions and decisions during self-help groups are actually taken during these meetings. And so they either occur actually early in the morning or late at night because that's when people are free. Otherwise, they're usually working out on their farms. And so here is a group meeting taking place at night. So the women that you see actually around the edge here, these are all the members of the group. And the woman that's here, she's the person that's conducting the current transaction. This fellow over here, he's not actually a member of the group, but the group has hired him for a small fee to keep their records on their behalf. And the reason for this is that none of the group members themselves have the literacy or the training to be able to do that themselves. So he's the person that they've hired to do this instead. So this was our first set of observations that we were starting to generate. So one question we had was that even if the group members themselves were not literate, how are they confident that their transactions were being captured accurately? How are they having trust in this whole system? And how are they feeling comfortable with the process that was going on? So we asked this question. We were like, if you don't have an education, if you're not literate, then how are you actually making sense of all this? How do you trust that what's going on is being done in a way that's fair to you? And out of that came a lot of interesting observations. So the first thing the women mentioned to me, they were like, actually, we can kind of read and write numbers. You know, we have that limited numeracy, and that allows us to actually recognize numbers. You know, we take the bus, we look at bus schedules, timings, etc. So we have a little bit of numeracy that we can use to our advantage. So that was one initial observation. The second observation was that the women actually mentioned that they had memorized the format of these tables that were used to record the transactions. So for example, in this particular table, the rows represent different kinds of members, the columns represent different kinds of transactions. So a particular woman could memorize that, oh, I'm always the fifth row. That's where I know my name is always going to be. The third column represents my repayment for this particular month. So what I do every time I want to make sure that I'm being, that my data is being captured accurately, I always index to the fifth row, look at the third column, and make sure that the number I expect to be there is actually, in fact, there. So these are actually important ways that the group members themselves are observing the process and getting their own sense of satisfaction that things are happening in a way that they can be comfortable with. You know, the fact that they have numeracy and the fact that this paper artifact serves as an essential kind of structure for them to reason about the whole process and the data that's collected during that process. So with that kind of basic understanding, we decided to start designing some initial prototype user interfaces that may be able to capture that information digitally. And so here we are conducting a user study with such an interface. Here's the interface right here. And as you can see, we tried to maintain that same tabular format as closely as possible so the group members could use that as a scaffolding for understanding how the user interface is laid out and what data is actually kept where. So the way this whole process worked was that we were living in a small village nearby where a lot of these groups were living and having their meetings. And every day we would have a different set of groups come in and test a user interface that we had prepared. And we had organized the group members into basically homogeneous groups according to their educational background and literacy, so that when they came in, that there wouldn't be individual people that would be dominating the interaction or really taking over from other people. So we had to create these homogeneous groups. So every time a group would come in, we'd have a user interface ready for them to test, and we'd ask them basically their feedback on that interface, what they perceived from the layout. We'd ask them to perform some simple tasks and look at what they had trouble with and what they were able to do successfully. And on that basis, we were able to continually refine and improve the interface until we got to a point where it could be usable by most of the people that we were dealing with. And that was really our goal through this whole iterative process. So here's one of our final design artifacts, which was one of the most successful artifacts that we designed. I'm not going to go into this into a lot of detail, but I do want to talk about one aspect that made it successful. So initially, when we brought this laptop, it wasn't exactly this laptop. It was another laptop. It was very shiny. It was silver. And we'd put it down in the middle of the village, and we'd say, come use our user interface. We want to do tests, you know. So people would kind of gather around. The NGO would kind of organize people together ahead of time. So they'd come up to it, and they'd be like, that's an excellent interface. Well done. Bravo. Beautiful interface. Great job. And we'd be like, well, you actually have to kind of touch it and use it to really see how it works. You know, that's part of the whole thing. So they would be like, no, I'm OK. I'm cool. I don't need to touch that. And there was a very good reason for that. You know, from their perspective, this was a very expensive and kind of foreign technology. You know, there was this whole perception that if I damage this, I'm going to have to take many, many loans to repay that. You know, I'm already behind in my repayments. I don't want to take that risk necessarily, right? Also, all the keys were in a language that they didn't understand. It didn't mean anything to them. So there really was no reason or no incentive for them to engage with this technology. They were just afraid of it, and they were like, let's just, you know, be quiet, and eventually this guy will leave. You know, they all leave eventually, right? So how to get over this? You know, from the perspective of testing the user interface, it's actually kind of essential that people are touching it, people are engaging with it, people feel confident in working with it. So how do we get over this hump? So we thought about this for a while, and we really realized that we have to make it safe in some way. We have to make it safe for engaging with this technology and how to go about doing that. So we told people this area that's yellow in the bottom of the screen, that's a relatively safe area. If you move the mouse around in there, and we explained to people how to use the mouse, if you move the mouse around in there, nothing drastic is going to happen. You're going to be safe in that area. And moreover, we said that these actually little great things, they're buttons. You can, if you press this big button, something interesting might happen. Maybe you should go about doing that. So finally, maybe one of the more adventurous, ambitious, confident village group members would come up and they'd start using the mouse. And initially, they'd just stay in this yellow area because clearly this gray area is not safe. So they'd kind of move around in this area, very careful of not crossing this line, and moving around in the yellow area. And then eventually, someone might go over a button and they might, press the button. And so when they press the button, that would repeat actually the meaning of that icon in the local language, which is Tamil. And so the village members would all of a sudden hear this box speaking Tamil, which is their language, a language that they know and understand. So all of a sudden, this is not a weird, shiny box. It's a Tamil-speaking weird, shiny box. This box speaks their language. It's a language that they understand and they can reason about, right? So that was amazing. As soon as they heard this box speaking in Tamil, there was a complete qualitative shift in terms of how they perceive this technology. There was a distinct bridge between the user and that device. It was speaking a language that they could understand. And this is very similar to the fact that if you were going to go abroad somewhere, end up in a very unfamiliar place, and you met someone that spoke a language that you understand, for example, English, you would also feel very comfortable. You would be like, okay, I can speak to this person. There is some bridge of communication between me and this other person. In the same way, they all of a sudden had this bridge of communication between them and the technology. Moreover, through this process, by repeatedly pressing these buttons, they'd hear it speak Tamil, and they'd get all excited. They'd be like, yeah, I did that. I made that box speak Tamil. And they would do this real sense of achievement that came through that process. Moreover, what that interface is repeating when they press that icon is actually that meaning of that icon in the rest of the application, right? So by repeatedly pressing on these icons and having everyone hear that repeated, they're actually learning the meaning of all these icons. So they're building up the symbol set that they can reuse later on in the rest of the application, and they can understand what all of these abstract icons then mean. So later on, if they were to go press on this button, they would have already a kind of sense of what that button is supposed to do, even if they didn't completely understand what that icon is supposed to represent. And so when they pressed it, they would have a sense of what that next screen indicated and what the next step was in the task. So that was a real feeling that we're starting to get somewhere here. We're starting to make some progress. As a result of this, we basically published a set of design guidelines for designing user interfaces accessible to such populations. And so we were basically in the village for around 2 months. We included 32 users in our trials. And the guidelines were things that we've already discussed. The fact that the paper formats were very important, that this local language audio builds trust, the fact that there is greater numeracy than literacy so that we can use both numeric input and output for improved accessibility. And these were just some of the results that we generated and decided to write about. So the next step, as a computer scientist, is really to build something. Our goal is to engineer a system that's going to address both the needs and the capabilities that we've observed, and how is the best way to go about doing that. So at first I'm going to talk about three elements of our design that played a role in its eventual deployability and success. So the first thing is this idea of using agents or rural service providers. So one thing that we observed during our time in the village is that there is a class of people that actually are educated. They're typically younger. They may be anywhere from, in their late teens to early 20s or mid-20s. They've gotten an education because access to education has improved actually a little bit in certain areas of India. But on the other hand, there's not necessarily employment opportunities for them in the villages. They're not really being recruited by IBM and Microsoft. So they have to find ways to actually be employed in a way that's going to leverage their skills. So this kind of underutilized labor pool is used by many kinds of organizations in providing services in rural areas. They're used by kind of the public health sector as kind of health intermediaries. They're used by microfinance organizations as loan officers or field staff. They're used by nonprofit organizations as again, field staff. And so all of these are actually being used in such a way as they provide an intermediary between the villagers and the formal organizations that's trying to serve them or provide services. They have the advantage of being from that local area, being familiar with a lot of the cultural and the context and some of the people even. And so that really gives them advantage in being able to work in these kinds of areas. The second thing was actually the hardware platform. So at this point, this was around around 5 years ago, mobile phones were already being picked up very, very quickly in all kinds of developing regions, including China, India, Africa. And besides the fact that they're already being used ubiquitously for voice communications and for text messaging, they also have a number of user interface features that were very synergistic with the features that we have outlined in our first set of results. So first of all, they had a numeric keypad, which was immediately recognizable to billions of people. They have speakers and a microphone that automatically supports audio-based interaction. They have a battery that typically will last a couple of days, so you can use it in areas of intermittent power. And they also, some of them even have local storage, so that you can cache some data on them. And that means you don't need to always have connectivity. You don't need to always have an online active connection. And so all of these things means that we could potentially use this as a hardware platform for providing various kinds of services. Moreover, the fact that it's a mobile device means that these field staff or these agents that I described earlier can use these devices to go from village to village and to provide different kinds of services. So these are all things that we thought could be advantageous. On the other hand, from a user interface perspective and from a systems perspective, there are certain limitations to mobile devices which make them less than ideal as kind of a hardware and a software platform. So first of all, they have a small screen, which makes it very difficult to kind of do a typical point-and-click based user interface. The fact that you have a numeric keypad means that equally hard to input text. And also, up till now, there has really been very little standardization or very few even open software platforms for one to actually being able to program mobile devices. So all of these are limitations which makes it difficult to actually build systems using mobile phones. So for the user interface limitations, we thought this idea of paper user interfaces could be really promising. And so paper user interfaces is kind of a research idea that has a long tradition in the HCI community, the human-computer interaction community. And the basic idea is to leverage the affordances, the cheapness, the accessibility, the familiarity of paper as a part of the user interface. So far, we haven't really seen really wide adoption of this in the developed world. But what I would like to propose is that it really could be the killer application for the rural developing world. And the reason for that, one of which I already described, is that lots of people locally already have a lot of familiarity with paper formats. That familiarity could be leveraged now in terms of digital user interfaces. And the other advantage is that by having this kind of readily accessible and cheap technology on which to perform operations and capture some data, you can actually optimally use technology. Like you can do basically most of your data entry and most of your decisions and operations on the paper form, and then only capture that data once using a mobile device and kind of taking optimal use of that technology when you actually, in fact, have access to it. So in the case of the groups, they can maintain their records on the same paper forms, and then only when someone had a mobile phone handy could they have to capture all that information in one fell swoop. So in some sense, time sharing the mobile device. So leveraging these three principles, this is the system I actually ended up building. It's called CAM. It's a toolkit for building paper-based mobile phone applications. It consists of three components. One are these CAM forums, interactive paper forums. Then there's a CAM browser, which is a mobile phone application to process those forms. And there's a scripting language that actually specifies the interaction between the mobile phone application and the paper forms themselves. So actually how this works, here's an example form. This is not a form for microfinance. This is actually a form for inspecting an organic coffee parcel, but I'm just using it as an example here. So the way this would work is that the data would be entered on the paper, and when you were ready to capture that data digitally, what you would do is you'd take the mobile phone with the camera, you'd focus on the barcode for the section of the form you were interested in processing, you would click to take a picture, the phone would interpret that barcode, know automatically what form it was, what section of the form it was, and then it would go about launching a sequence of prompts with audio, as you just heard, to guide the user through capturing all of the data from that particular form. Once the data was populated, you could again use the camera phone to focus on individual barcodes, and that would allow you to review the values you've already entered. Now, this is useful for the case where, for example, in the group context, you want to demonstrate to the group member that, yes, in fact, I have captured your data accurately. What you have thought I have entered, I've actually entered, so you can actually show the group member that, yes, the phone has the same data on it that the paper form does, and you can get that mutual validation. So some of the properties of the system, some of the key features. One, there's this tight linkage to paper practices. It kind of retains paper as the local authoritative record, which is important not only from a user interface perspective, but also from a data management perspective. If the phone gets lost, if the data gets lost, you always have the paper record, which really is important for maintaining independence of the local operation. You're also, in some sense, we're not really optimizing for saving local labor. As I mentioned, there is an underutilized local labor pool, so we're not necessarily doing any recognition. We're not automatically doing OCR. We're not interpreting the text or the images that are recognized. We're asking the user to re-enter all of those values, and that's because optimizing for local labor is not necessarily what we're trying to achieve here. There is plenty of that available. From kind of a programming perspective, there's a very simple scripting language that allows you to specify the interaction with individual forms. So it's very easy to specify how a particular form should work, and so that makes it easy to program. The scripting language also provides support for things like capturing data as audio streams or as images or as video streams, and this allows you to capture text fields that otherwise would be difficult to capture by keying them in using the numeric keypad. And it also allows you to cache data locally on the phone. So it allows for basically disconnected operation where you can load some applications on the phone, have them be used offline, generate some data, and then later synchronize those back with the server. So in Microfinance, how this actually works for the self-help group application I mentioned earlier is that we designed a set of forms with these barcodes for the group members to record their transactions. Those forms are processed by field staff that carry these mobile phones. That data is then uploaded to a server using an SMS message. That server then generates reports that the groups can use both internally and for interfacing with the banks. And those reports are then printed and then delivered back to the groups. And those reports then can be used at the next meeting for deciding who needs to pay what, for deciding who should get the next set of loans. And also, when you go to the bank for a loan, now you can show them a balance sheet, you can show them profit and loss statements, you can show the current position of each of the members. And this really differentiates these groups as opposed to other groups that just show up with a stack of unfilled paper forms, and then deciding between these two groups is pretty clear for the bank's perspective. It's a clear decision. So I'm going to show a short video now of this system actually being used in the field. Here you see a woman capturing data from a form. And you can again hear the audio prompts coming as soon as they go through each of the form fields. And in this case, also the audio is really important. And one way we observe this is that when you were completed filling a form, the system would basically say, in Tamil, success, your transaction has been completed. And that was, for some reason, so funny or so popular because that it became like kind of a local idiom. Anytime you handed somebody something, they'd be like, success, your transaction has been completed. So it became this kind of local joke. Here's another kind of variant on this thing. So we built this kind of wooden box, which makes this phone kind of like a scanner. You put the form inside. There's a small hole on the top of this box. You put the phone on top. And now the interaction model is very simple. You just put the form in, you put the phone on, and you press the big black button, and it automatically walks you through the whole sequence of events. It also captures a picture of the form at kind of a fixed focal length that's really stable and gives you a clear image of the picture in case later on you want to audit that data or you want to be able to verify the data that was entered. So that was a different kind of interaction model that we tried out. Here you see actually the system being tested during an actual group meeting. And so this system has been deployed live in India since October of 2006. And it's currently being used to serve around 700 self-help groups by 17 field staff. And I'll talk about the evaluation of the system in the next slide. So the next step is actually evaluating the system. So the first step was actually doing a simple usability evaluation, seeing if this system could be used by the people we were expecting to use it. So the task was actually recording the transactions that were generated during a typical group meeting. We had 14 users. They were all field agents that worked with a local nonprofit organization. They all had at least a 7th grade education, so they were all basically literate. And we tested the system in kind of two contexts. One was a simulated context where we generated some fake data and had them capture it in our field office. And another was an actual in situ setting where we actually went to a group meeting and had the field staff capture the data that was generated during that group meeting. So the results were all favorable. The first result was that everyone learned the system. Most everyone learned the system within one setting of trying to learn it within 5 minutes. A couple of the users took between 2 to 3 sessions. It was efficient in terms of capturing this data. One form took, on an average, 30 seconds to process, and that translated to between 8 to 10 minutes to capture all of the data generated during one group meeting. Now, just for comparison's sake, earlier, all of the documentation processes for a group meeting could take anywhere between 1 to 2 hours, and that's because they had to capture all of the source data and to generate all of the reports and ledgers and statements, etc. So now, since we're automating all of this, we're reducing the time that each staff has to spend in the village for doing paperwork from between an hour and a half to 2 hours to 10 minutes, which means that each field staff can now serve many, many, many more groups, which improves the scalability of the whole SHG model. From an accuracy perspective, the error rate that we observed in simulated settings was less than 1%. And then when we actually took it into in situ settings, where we were actually capturing data from real live group meetings, there were 0 errors. No errors at all were made. And that really made us confident that the system was potentially ready for a live deployment. We could actually do this at scale and have it collect live data. Another test we did is we compared 3 variants of the system. One variant of the system had only text prompts, one variant had only audio prompts, and one variant had both text and audio. And what we observed was that in the text-only condition, there were significantly more errors than in the other 2 conditions. And that led us to believe that really users were really queuing on the audio prompts, and that was really driving the interaction as opposed to looking on that small screen and trying to read the text from that. So these are some of the results that we observed. So as I mentioned, the system has been deployed live. It's been done through a company that I co-founded called Eggaon Technologies, and it's being used in Tamil Nadu, India since October of 2006. So now I'd like to talk about a set of other applications I've built using essentially the same framework for essentially automating supply chain transactions, for collecting public health data and automating clinical protocols, and to monitor and certify agricultural cultivation. So I'll talk about these in the next slides. So in agriculture, what we've built is a system called Digital ICS. And this is an internal control system for agricultural cooperatives. So how the system works is that we equip farm inspectors that work with a local cooperative with this CAM-equipped mobile phone. And then they're able to go into individual farm parcels and document the current status of cultivation. That includes things like what kinds of pesticides and fertilizers were used, the status of the machinery used to process the coffee. These are coffee cooperatives, so they're producing coffee. The status of the machinery that's used to process that coffee, etc. And that information is then uploaded into a web application. From that web application, the head agricultural scientist that works for the cooperative is able to give feedback to the farmers so that they can mention if the farmers are having a particular kind of problem with a kind of pest or they're not able to effectively use a new kind of technique, they can directly give feedback to the farmer through this mechanism. It also allows them to decide whether or not certain farmers should be sanctioned or expelled from the cooperative because they're not fulfilling the requirements of the certifications that the cooperative has. So in the case that we're working in, we're working with coffee cooperatives in both Guatemala and Mexico. Both of these cooperatives are certified for organic cultivation, for bird-friendly cultivation, and also for fair trade. And so if the inspector or the evaluator observes that any of these requirements are not being met, they can either sanction or expel those particular members of the cooperative. Finally, once this data has been aggregated in this way, the system also automatically generates reports that the cooperative can use to manage their production, to be able to report to the various certifying agencies the status of each inspection and of each farm parcel. And that really reduces their efforts in actually generating all of these reports manually. So the actually underlying goal of the system is actually to maintain the quality and the certifications that the cooperative has. And this is being piloted this spring with over 1,000 farmers in Oaxaca, Mexico. And this work, I should mention, is being led by my student, Yael Schwartzman. This is another application we're doing in the public health space, and this is working with a clinical protocol called IMCI, Integrated Management of Childhood Illness. And this is actually distributed and published by the World Health Organization. And so what this basically is this paper flow chart that allows a barely trained clinical health worker to diagnose and treat a variety of important childhood illnesses. And this is basically a step-by-step process that allows, on the basis of certain tests and certain indications, tells the health worker how the treatment should proceed and whether or not that patient requires further referral to a health clinic or to a hospital. And it's been demonstrated that using this protocol can significantly reduce child mortality, and this was done in Tanzania in early 2004. So what we are trying to do is actually automating this protocol using a mobile device. So currently this is published in these paper formats, which are somewhat tedious to follow, requires a lot of training, and requires a lot of time and effort in terms of going through each of the steps. The mobile device actually leads the health worker through the protocol step by step, so there's very little requirement for training, and it's really much easier to follow. And our hypotheses are that doing it this way can really reduce the training requirements of deploying such a protocol. It allows you to dynamically update these protocols with regards to recent changes in understanding and design, and also could potentially improve the health workers' adherence to the protocol, which means that they will follow the protocol more closely than they would have otherwise. And that last fact we actually demonstrated this past summer in Tanzania. So we tested this with a local hospital, and we measured actually how closely the health workers follow the standard IMCI protocol using both the current practice, which is the paper-based chart, and the mobile phone, which guides them through that process step by step. And so we observed roughly 25 of each of the different kinds of sessions, and we demonstrated that actually using this mobile device can significantly improve health workers' adherence to the protocol in the sense that they follow the protocol more closely. So in the case of the paper-based practice, it turns out that only 61% of the time people were actually following what the protocol was telling them to do. When using eIMCI, that went up to almost 85%. In terms of actually giving the final advice to the patient, it turns out that only in 57% of the cases with the paper-based flowchart were the health workers actually giving the advice to the patient. When using the eIMCI, that went up to more than 77%. So this basically shows that if using IMCI can reduce child mortality, it stands to reason that following IMCI more closely is also going to reduce child mortality or lead to better health outcomes. So this leads us to believe that this will, in turn, improve health outcomes also. So just talking a little bit about some future work I'd like to do. Oh, sorry, I should mention that this work is being led by my student Brian Dorenzi, who's up at the University of Washington. And it's also done with a collaboration with an organization called D-Tree, which is based in Cambridge, Massachusetts, and Neil Lesh and Mark Mitchell, who work for D-Tree, and also Gaetano Borriello up at the University of Washington. So just talking about one element of future work, this is some stuff I'm working on with another student of mine named Yao Nakwa, who's also up at UW. So one thing I believe pretty strongly is that, yes, I've done this dissertation, I've built a set of projects, but really it's the local people that are going to have the best ideas of what their problems are and the best ways to solve those problems. And just to give a couple of examples of that, this fellow here, his name is Don Max Bala, and he lives in a remote valley in Guatemala. And so what he noticed is that no one in that village has phone connectivity. There's no phone connectivity that reaches that village, which is very important for that village because a lot of the people from that village have emigrated to places like the United States to find better work. And so that community really felt disconnected from the people that had left, and we're really having trouble with that. So what this guy noticed is that, yes, we're in a valley, but that means there's hills on both sides of us, and it's likely that one of those hills is going to be able to get a cellular connection. So what he went up and did was he built a small shack up on the next hill, he put up an antenna, he put up a phone there, and now every morning he walks up to the top of that hill at 9 in the morning, and he's essentially a receptionist for the entire village. He takes phone calls, writes down little paper messages. At the end of the day, distributes them to the people in the village. People write down the responses on the same paper, and then he carries them back up the next day and then calls all those people back, right? So, one could imagine using the system I described earlier, CAM, how you could do that a lot more effectively, but I'll leave that as an exercise for the reader. So that's just one example. This fellow over here, he's also interesting. So one problem he was having, this is in India, so it turns out that his farm was around 2 to 3 kilometers from where he was living in his village. And so due to the irrigation schedule of the crops, he would often have to go sleep out in the farm or go out there in the middle of the night just to be able to turn the water on or off, just to manage the irrigation scheduling. So he reasoned that maybe this is not a good way to spend my time, going and waking up at 3 in the morning and walking 3 kilometers and turning the water on, right? So what he did was he mechanically hooked up one phone to the water spout. He kept one phone with him, and based on the ring pattern of the phone, he's able to turn that irrigation on or off automatically now. So this is just one innovation that he was able to generate locally. So what these two examples demonstrate is that often local people have the best ideas. They know what their problems are, and they know how to fix them. We just have to provide them better tools to be able to go about doing so, right? And so this is the next set of work that I'm hoping to undertake, is actually to build better tools for local people to build their own communications and data management systems. Well, how did that slide get there? So this is kind of my long-term vision. So I think, as a civilization, as a society, we're facing a lot of deep and hard problems. This includes things like, in the face of kind of growing population, how to maintain equitable economic development. With that economic development, how to maintain things like environmental sustainability, and also do that through the free and participatory process where everyone feels represented and no one feels excluded. Now, I'm not saying that information technology can solve all of these problems, but it's one of the great tools that we have, is that we can apply towards addressing these really fundamental problems of our time, and that's one of the things that I'm seeking to do. Also, this idea of decentralization, by making people have more decision-making power and more empowerment locally, that also can contribute to achieving all of these goals. And actually, if I look at my dissertation, what I really think I've done is to build an infrastructure that allows information technology to be used in a decentralized manner by local communities that did not have access to it previously. So just some final thoughts. I think the work that I'm doing here is really driven by designing for real people and real problems. And that always has primacy in all the projects that I undertake. If we can't find a hard or deep technical issue, that's fine as long as we're solving real problems that are important to real people. And I think this approach of really being problem-centered and focusing on the problems that people think are important rather than the technologies that people think are innovative really attracts a different set of students, people that are problem-centered, really energetic about changing the world. And I'm really happy to be able to work with a lot of such students already. And I think working on these kinds of applied problems is really important to really carry through the work towards some real impact. And that's both what sustains the collaboration you have and the credibility you have with your local partners. For local partners, the results are not research papers, they're not fundamental insights, it's actually changing the world and changing the way people live. And that's really what drives this work and the goal I have in doing this work. So thanks very much. Thanks to all these people for helping me do this work. Thanks for my audience, and happy to take questions.
Do we have any questions here? Don't be shy. I'm going to start calling on somebody.
Yeah.
During your talk, you mentioned trying this out in more than one place. Did you try it out in a few other continents or other programs? Because I think you've spoken only about Tamil Nadu or something like that. So.
Yeah, so the microfinance work I described, that's been primarily implemented in South India. It's also being now implemented in Sri Lanka, but we're focused on South Asia. The work I described in public health, that's being all done in Africa, in Tanzania and Rwanda. And the work I described around kind of agriculture and agricultural cooperatives, that's all being done in Central America, in primarily Guatemala and Mexico. So that also leads to another kind of issue in this, is actually how to sustain this work going forward. And so in India, I was able to form this company that actually deploys these systems commercially now and supports them and maintains them. And in all these regions, for all these different kinds of applications, we have to eventually move towards building that same infrastructure and support network.
You might have mentioned this a little bit earlier, but for the user, whenever they take pictures of like the paper and whatnot, to what extent does the camera have any recognition software, perhaps, where it could actually take some of that data versus the user having to punch it in?
Right. Yeah, I did address this earlier. So it doesn't do any recognition, right? And there are a variety of reasons for that. One is that the metric we're not optimizing for reducing local labor. It's just not a metric that we're optimizing for because local labor is available and it's cheap. The metric we are actually optimizing for is accuracy. We want to get the data as accurately as possible, right? And at least how it stands currently, humans are more accurate than automatic recognition software, right? And so that's the reason we took that decision. The other aspect is that if the system is going to make mistakes, correcting those mistakes is going to be a deeper user interface problem than just entering it right the first time around, right? So what I can imagine how recognition might play a role is that it might be able to populate default values, and then the user could choose to correct them or not correct them. That's one approach that we've thought about. Any other questions? Yep.
Have you done any work in, incorporating efforts with something like Vodafone's Impresa or money transfer, or coordinating your software to link up with banks so that you can facilitate money transfers or anything like that? And what is your thinking about programs like that?
No, that's really an exciting development in Africa, allowing the actual transfer of money and to be disintermediated from person to person. And I think that's a really promising development. And actually, I've just started discussion with a few people at the World Bank and at the Gates Foundation about how we can improve the consumer uptake of these technologies. So far, the kinds of efforts that you've mentioned, they're largely restricted to people that are already literate or already have some technology handy and are able to use that technology. It's not necessarily being absorbed by all the other people who might want to transfer money or to do some kinds of exchanges like this. So the exact discussions I'm in with them right now are things about how we can increase the uptake of such services. And one key element is the user interface, some of the stuff I talked about. Another key element is actually the trust and the security of the system. So how do you feel confident without getting a paper receipt back that that transaction has been recorded and the recipient has actually gotten the money that you intend to send to him? So these are some of the research questions that I think come up when you look into those kinds of applications. Yep.
I noticed that with your paper forms, it seemed like you actually had two different kinds. You had the ones that were just sheets of barcodes that people would take a picture essentially of the barcode they wanted. And then you had ones that were the full sheet of paper with some text entry places and presumably also the same kind of barcode on them. Mm-hmm. Could you talk a little bit about your experience with the two different kinds? And also, sort of about the availability of, printers and papers and whether that has, any kind of effect on that. And also, perhaps, with your sheets with just the barcodes and, presumably text in the local language underneath explaining what they are, whether there's any reason why you couldn't just have that same, essentially, menu on the phone.
Mm-hmm. Right. So I'll address, there's a bunch of questions there, so I'll try to pick 2 or 3 of them and answer them. So one was just the availability of papers and printers, right? So in practice, we usually print all of these forms in bulk at very high volume, which makes it very cheap to print each individual form. So that's how we get around the printing and kind of cost issue. With regards to just having a menu on the phone, actually, in fact, that's an alternative way you could implement this, right? But that, in some sense, that abstraction of navigating through a menu is only accessible to a certain class of users, and so you have to assume that class of user. The other assumption you have to make is that you have a relatively limited number of forms you're trying to access. If you have 10 forms, I think it's fine to use a menu and to go through it that way. If you have 1,000 forms or 500 forms, it seems less scalable. So it turns out in the system, we have shortcuts so that you can select a form by menu, or you can index a form using a short numeric code. Both of those are actually used in practice once people have familiarity and people are doing the same task repeatedly. I think you'll only see the advantage of this kind of approach when you expand the user base and expand the number of forms that you're trying to support.
So does the software on the cell phone do any kind of work, or are you looking to do anything to encourage honesty, essentially, by making checks or doing all of these numerical calculations? Say every user gets to enter in her sum for the week herself on the cell phone, and it's immutable by anyone else.
Right.
Or is that a possibility? Or
no, that's an interesting idea you just proposed. Right now what we're doing is basically performing some simple calculations on the phone itself, so that, for example, after you've conducted the whole group meeting, you should have a sense of how much money should be left in the kitty, right? So it automatically generates that value at the end of the meeting. You should expect to see 575 rupees in the kitty, right? So you can verify that according to what's actually in the kitty and to get immediate validation that you have that check and balance done, right? But actually expanding those checks and balances to improve the kind of transparency during the group meeting is also, I think, an interesting research question. How to have mutual observability of that process using a very small device is, I think, difficult.
Yeah, we use the microphone so the other campuses can hear us. So,
your work represents a paradigm change for people who have observed a little bit in the computer industry. from working with for-profit businesses mostly, and on very technical applications to what you have here is a very non-profit social kind of purpose. So I mean, I'm wondering whether, given that you've been studying in computer sciences, that you've had any specific desire or purpose or observations in that you might want to share with us in terms of how that fits, how that makes you fit with or compare with the other paradigms of what computers technology has been used for.
Poorly? No. So I think there are various ways to answer that question. So I think given the state of the kind of systems that we've observed, they're just barely getting to the stage of automation, right? And so in the kind of mainstream computer industry, we dealt with all these things around automation of basic office tasks anywhere between 20 to 30 years ago, right? And so a lot of the work we do in this space seems kind of, in some sense, low-tech or trivial from a strictly technology or computer science perspective. And I think that's just the nature of where the market is right now and where the problems are right now. I look at this as kind of an experimentation phase where our real goal is just to build systems and see how we can automate some of these processes, see the problems that come up, see the approaches that are successful versus not successful, rather than trying to always compare ourselves to where the West is right now and how that looks relative to the West. That's not the goal of this work, and that's not the emphasis of the work. From the perspective of for-profit versus not-for-profit, I think that's a very interesting question, and I think it runs through a lot of debate around technology. So technology is seen as this kind of egalitarian idea that would make the world in some way better, but that's not necessarily reflected in commercial practices around technology, right? And so I think there's an interesting debate here about, technology and its role beyond kind of simple economic value addition or simple commercial incentives. Can it really be seen as a tool or a mechanism, as a vehicle for changing the way things are done, right? And I think this relates to things like open source, intellectual property. I think all of these kinds of themes are related to what I just said, and I have to admit that I'm an idealist. I want to change the world, not live within the existing structures, right?
All right, well, if we're out of questions, we're out of time. And thanks again to Dr. Tapan Parikh for speaking today.